Right. We did a few of these 2 weeks ago. Have a go at this one. How are we gonna end? So, do we remember how to start these? The circle, yeah. So we do our little top right corner, we make our little circle in the top right corner. Sorry? Yeah. 2 6 squares up again. So up here in the top right, we're drawing our little C, A, S. So root 3 over 2, guys, is what for cost? It's 30. And where is it going to be in? It's going to be in C, A, S, T. It's going to be S and T. Why is it going to be in S and T? Why is it going to be in C and A? Because it's negative. It was positive, it means C and A. Which line do we always work on? E, horizontal. We're always working on this. Alright, don't forget that. We're always working on the horizontal. So as I said, guys, we would have done these week 1 or week 2 of after Halloween. Might have a little run through the first one, guys. Memory is a small bit dodgy. So, as I said, we draw our little diagram. C, A, S, and T. So, the cos of 2x is equal to minus root 3 over 2. 2x is equal to the cos, we go to cos of root 3 over 2 from our logbook and we get? You said it was 30, isn't it? It is 30 degrees. So, we also know it's negative, don't we? So we go to our, has to be in sine and has to be in tan if it's negative. Can't be in cos, can't be in odd. So we go 30 degrees back up this way, and we go 30 degrees down that way. So if you go 30 degrees off 180, what's this up here going to be? 150 degrees, and what's down here going to be? 210 degrees, isn't it? So, therefore, 2x is equal to 150 degrees or 210 degrees. Right, I don't want 2x, I want x. So divide across by 2, 2, 2. X is equal to 150 degrees or, sorry, come on, Paddy. 150 divided by 2, which is 75 degrees or 105 degrees. Right. Still haven't answered the entire question. Find all the values. What's that mean? Sorry? Plus 360 n. Remember we did that for the find all the values, the 360 n when you want all the values? So you have to go and say 2x was equal to 150 theta plus 360 times n, or 210 degrees plus 360 times n. Very important to use the original values, not the one you divided across by 2 by. Is that okay? Use the original values you got. Now we must divide across by 2, 2, and 2, 2, and 2. So x is equal to 75 degrees plus 180 times n, or 105 degrees plus 180 times n. And you know what I do then? N equal to, n equal to, and n equals to 2. You keep going until it goes above 360 degrees. So I say n equal to 0, n equal to 1, and n equals 2. So that's 75 degrees plus 180 times 0, which is 75 degrees. 75 degrees plus 180 times 1, which is 155 degrees. No, it's not 255 degrees even. And then you try 75 degrees plus 180 times 2, which is going to go above it because 280 times 2 plus 75 is 360 plus 75, which is 435. So that doesn't work. You didn't go over and do the same to our 105 plus 180 n, which is 105 degrees plus 180 times 0, which is 105. 105 degrees plus 180 times 1, which is 285 degrees. 105 degrees plus 180 times 2, which is going to strike out. It's going to be too much. Final bit to the question, what are my 4 answers so? 75 degrees, 105 degrees, 255 degrees, and 285 degrees. They're all the values. So, as I said, on the homework there is easily 10 examples of those we've done before, right? So, make sure you go back and look at them. They come up. Guaranteed. I think it's 1 in every 3 or 1 in every 2. You'll see now as we go back to them. Right. That is when it's 360 degrees. If we look at the bottom bit, and you know what we're going to do, we'll be doing in the bottom bit. Done these before, but in the examples. 4 image onto the circle, and you know what we're doing in the bottom. Not a substitution. What did we do before we did the circle there 2 weeks ago? We did that. We did the right angle triangle. Exactly. How do we know this is the right angle triangle? Being 0 in it. First thing we're going to do is instead of drawing a circle, this time we're going to draw a right angle triangle. Exactly. We're going to draw a right angle triangle. So, TRIG makes up 1 short question and 1 long question on paper 2, minimum. So that's 25 marks for a short question, and minimum usually is 50 marks for one of the long ones. If it's question 9, if it's 7 and 8, if we anywhere up, start 70 marks. You could have 95 marks to over 300 in just trigonometry. So that's a lot. It's like algebra and functions on paper 1. Most of paper 1 is algebra and functions, most of paper 2 is trigonometry and positive stats. They're the main subjects, main topics you need to hit. Like, if you get 95 marks in 3, that's only 1/3 of your paper, 33% of paper. It's important me nail this. What's our little poem to remember right angle triangles? Or whatever you remember. Sakatoa or City Old. Harry, Kata herring, trawling off America. Once again, there's 4 or 5 examples in the homework on the sheets that are written out the solutions of these. As every other teacher who went out them sheets, the only questions they put in there are ones that could come up. So I just want to do wrong. 2 was put together. So it's cost, this is what we cost is, and that's what we are. Cost. What form do we want to use then? Get to our set. Pythagoras. Here, we're going to use Pythagoras here and we get to our set. then sine it to a, I'm going to figure that out. Formula log, exactly. Formula log, sine it to a, formula log. Right. Have a little look at it. So, right angle triangle. It's the cos of A, so our angle inside there is A. Doesn't make a difference which way you draw your triangle face, and your size will be the same. So, the cos of A is equal to y over 2. So, cos is adjacent over hypotenuse. So, if this is A, this is our adjacent, and this is our hypotenuse, isn't it? We want to get x over here, or opposite. So, x to be 2 to be squared is equal to x to be squared plus y to be squared. So 2 to be squared is 4 is equal to x to be squared plus y squared. 4 minus y squared equals x to be squared. The square root of 4 minus y squared is equal to x. So this side over here is the square root of 4 minus y squared. Is that okay? So, we now have our three sides. What's our formula for sine? It is sine a to a 2 sine a cos a. 2 sine of a cos of a. So, we know what our cos of a is. Our cos of a is y over 2. We have to get our sine of a. And our sine of a is equal to silly old Harry, so opposite, which is root 4 minus y to be squared over hypotenuse, which is 2. So that's 2 times square root of 4 minus y squared over 2 by the cos of a, which is y over 2. Is that okay? So, we have 2 times y times the square root of 4 minus y squared over 2 times 2, which is 4, which is equal to 2 and 4, y times the square root of 4 minus y to be squared over 2. And that's your answer. Is that okay? Very, very important. Can't break that down into 2 minus y. Is that alright? That can't be broken down into 2 minus y because there's a minus in the middle. Can't break down two figures separately underneath a square root. If that was 4y squared, yes. 4 minus y squared, no. Is that okay? 4y squared you can break down under a square root. 4 minus y squared, because there's a minus in the middle, can't break it down. We all happy there? Right, let's do another one that's like that. Right, 2016, paper 2, question 3. What are we going to do on the top? We did these now as well. we would have done these the week before last. What do we reckon on top? So we kind of looked at 3D problems last week. These are more lower types of 3D problems. They're mainly confined to the shorter questions. The 3D problems are generally the longer questions. Right. When you're doing these, you pick a side. You either attack the right or attack the left. You start seeing things like cot. Attacking the side. The right and attacking the left. Any idea? Yeah, command. Add them. So I'm going to change the top from. We're going from product to sum or sum to product. So regardless, we're going from sum to product. So on top we have the, anyone any idea what's something? Cos of A plus cos of B over that. Sine of A minus the sine of B. And these are on page 15. So before you start, make sure you label what's A and what's B. Alright, so we write out some of your copy and literally write over what's A and what's B. And then you follow the formula. So our formula is cos A plus cos B. Top left hand corner. If you're wondering what cot is, it tells us what cot is on page 13, I think. Yeah, cot is on page 13. Let me slow it down. I'm going to jump on the beat, and that is cos 2 theta rule in our log. You can use either, but I do the one on top. This is really low and cos squared by 6. The rule on page 13 is not by corner. You can use that one as well. Right, I think we're all neat on the first bit, so let's have a little look at the first bit to make sure we're all okay. So, show that cos of 7a plus the cos of a divided by the sine of 7a minus the sine of a is equal to cos of 3a. So this is the page 15. This is cos a plus cos b rule. So, this is my a, this is my b, this is my a, this is my b. So it's 2 times the cos of 7a plus a over 2 by the cos of 7a minus a over 2. That's 2 times the cos of 8a divided by 2, 4a by the cos of 6a divided by 2, which is 3a. And then we do sine. So it's 2 times the cos of, for sine, for the bottom line we're on now, it's cos of a plus b, which is cos of 7a plus a over 2 by the sine of 7a minus a over 2. So that's 2 times the cos of 8a divided by 2, which is 4a, by the sine of 6a divided by 2, which is 3a. Put them over each other. 2 cos 4a minus sine 3a. Multiplying by 2, it's gone. Cos of 4a is gone. You're left with minus cos of 3a over minus sine of 3a. Minus divided by minus makes that a plus. We go to the rule on 13 of our logbook. What's the cot of a? Cos a over. So cos of 3a over sine of 3a will leave you with the cot of 3a. Because the cot of a, top left hand corner of page 13, is cos a over sine. Is that okay? Good stuff. And that was 15 marks there. Just using rules on logbook, which isn't bad. This one down here, once again, take out the logbook, applications, page 14, is it? Now, on the, we'll say the bottom half of 14, the top left of the bottom half, we have 2 rules for cos 2 theta. If they offer you the cos squared a minus sine squared a, I use that. Just the reason I use that one is if you look at page 13 of logbooks. That one on top, cost squared A plus sine squared A is equal to 1. That takes you over an awful lot of task-based questions. If you can use the one on top for the cost of 2A, not the one underneath. So we're leaving cost squared A up through cost squared A minus sine squared A equal to 1/9, and then trying to figure out what cost A is, or cost theta is. You just replace the A with theta. Is that okay? I'd be floating around with that. We're looking for cost of theta. We're going to try your linear science. Try your linear science and see what you can do. Okay, I suppose there's a rule in the top right corner for being so a lot of trouble on this. You can rearrange that over here. We did 1 or 2 problems there 2 weeks ago. We can rearrange that formula. And we rearrange it with sine squared over the equals bracket, or you can bring 1 over the equals bracket and rearrange it to suit you. Just on that rule, guys, sine squared A is equal to 1 minus cos squared A, or cos squared A is equal to 1 minus. That's the same rule as 3 times, which you can rearrange. It's like bringing x over math on that time. Yeah. me one more little minute and go on. Right guys, let's have a go at it. So, the cos of 2 theta is equal to 1 over 9. The cos of 2 theta is equal to cos squared theta minus sine squared theta, and that's equal to 1 over 9. As I said, we want cos in the answer, so we're going to get rid of sine squared. So that's cos squared theta minus 1 minus cos squared theta is equal to 1 over 9. So that's cos squared theta minus 1 plus cos squared theta is equal to 1 over 9. That's cos squared theta plus cos squared theta is equal to 1 over 9 plus 1. Cos squared theta plus cos squared theta is 2 cos squared theta is equal to 1 over 9 plus 1, which is 10 over 9. Cos squared theta is equal to 10 over 9 divided by 2, which is flip it and multiply. 2 over 1, flip it, 10 over 18. So 5 over 9, sorry. That is then another way of saying cos squared theta is cos of theta to be. Cos of theta to be squared is equal to 5 over 9. Cos of theta is equal to square root of 5 over 9. Cos of theta is equal to root 5 over 3. And they want it plus or minus because it can be plus or minus. Is that okay, guys? Right, let's look at another something little thing like that. Right, this one is slightly harder. 2015, paper 2, question 5. Paper 2, question 5. Prove that tan of A plus B is equal to tan A plus tan B over 1 minus tan A plus tan B. What are we going to look at? What's your idea? You want to pick the left or you want to pick the right? Tan A plus B. Anyone know what the formula for that is in a row? Sorry? So we can't use that one because that's just straight out of the lab box. So which one do we want to have to use? Prove that tan A plus B is equal to tan A plus tan B 1 minus tan A. Right, pause. Shit, this is wrong. Right. We gotta change this. We gotta change the tan of A plus B into an idea. Tan is, what's the tan in H of B? Sine of A plus B over cos of A plus B. Because tan is sine over cos of A sine and sine over cos. Yeah. So that's the sine of A plus B over the cos of A plus B. What we're going to use, we're going to use our formula for sine of A plus B over the cos of A plus B. What's the rule for sine of A plus B? Sine of A plus B is sine A cos B plus cos A sine B, isn't it? And then on the bottom we're going to have cos A cos B minus sine A sine B. Does anyone know what might be the most important thing here to give this away? Just looking at it there now. Putting on a few copies. What's going to help us get the right answer here? So all of what's the most important thing there? Going to help us figure out what to do here. Just looking at it. Alright? And the only way you can get a 1 this is if you divide it by itself. So that's how you get 1. So, looking at that, what are we going to have to divide across by to get Anyone, any idea looking at a copy? What are we going to have to divide across by? Look at its position. What are we going to have to divide everything across by? So I put it up on the board so it might make a bit more sense. So we said we're changing 10A plus B into the cos of A plus B over the sine of A plus B, which is the cos of A plus B is cos A by cos B minus sine A by sine B. Should be the way around, is it? Sorry. Sine over cos. Of sine, which is sine A cos B minus sine A sine B. So, if you look at the position of everything there, which one corresponds to one? Which one of those four terms corresponds to one? Am I doing something wrong again? Sine A plus B is sine A cos B minus of plus cos A. Look at the bleeding diagram. So sine of A plus B is sine A cos B by cos A sine B. And cos of A plus B is cos A cos B by minus sine A sine B. Yeah. Thank you. Read the bleeding diagram. Right. Thank you. So, which one corresponds to the one? Looking at it. Is it nearly position wise? Cos A cos B. So we want to get this to 1, because that's the most important one we're going to get. So we're going to divide everything by cos A cos B. Cos A cos B, cos A cos B, cos A cos B, and cos A cos B. So as long as you divide one part, you can divide all these. So what we're going to do then is we're going to put sine A plus B, that should be sine of A. We are going to put sine A cos B plus cos A sine B. And we're going to divide it by what's there, which is cos A cos B. Divided by cos A cos B all over cos A cos B minus sine A sine B divided by cos A cos B cos A cos B. As I said, just to jump out to me, jumped out to me, but I need to get this bottom left corner back to 1. Right, your thing's going to start working out for me now. Right, what's going to happen here? Cos B is going to knock. What's going to happen over here? Cos A is going to knock. What's going to happen here? Goes to 1. And what happens over here? We have to work with this a minute. Right, knock all those, see if you can make what's on the screen. 1015, paper 2, question 5. Yeah, not a nice one at all. Right. These knock. These knock. This goes to 1. So, sine A over cos A leaves me with tan of A plus sine B over cos B, tan of B, cos A, cos A, cos A, cos B divided by cos A, cos B leaves me with 1 minus what's sine of A, sine of B over cos of A, cos of B? Tan A by, and what do they want? They wanted tan A plus tan B over 1 minus the tan A by the tan of B. As I said, that wasn't nice one. Right, we should all be well able to get part B. Another one of these. What are we doing? Unit circle, CAST, find all the values for lunar plus 360. Let's see if we can get our full 15 marks down here. This is reduced to 10 marks that year. Right, we have a little look at it, guys. C-A-S-T. So 3x is equal to 60 degrees, x equals 20 degrees. Is that alright? So up here then, in all, this point here would be, this point here would be 20, and this point up here would be 160. Exactly, right. So, if we use the original amount though, very important, because we're getting all the values, this up here is 60 and this up here is 120 degrees. Is that okay? So 3x is equal to 60 degrees plus 360 n, or 120 degrees plus 360 n. Divide across by 3. X equals 20 degrees plus 120 n, or 3 into 120 is 40 degrees plus 300 plus 120 n. Is that okay? Right. N is equal to 0. Therefore, it's 20 degrees plus 120 times 0, which is 20 degrees. N is equal to 1, which is 20 degrees plus 120 times 1, which is 140. N is equal to 2, which is 20 degrees plus 120 times 2, which is 240, and 20, which is 260 degrees. N is equal to 3 is 20 degrees plus 120 times 3, which doesn't work. Too big. So that's 40 degrees plus 120 times 0 is 40 degrees. 40 degrees plus 120 times 1 is 160. And 40 degrees plus 120 times 2 is 240, and 40 is 180 degrees. So then your answers are 20, 40, 140, 160, 260, and 280. Is that okay? Right. A few more of these. Now this one is a proof you have to learn. 6 trig proofs. Just have to go and learn them. Simple as that. If you want your H1, you have to go and learn them. If you're looking to get over the line or go H3, H4, don't bother at all. Serious amount of effort and time that goes into them. If you want your H1, you have to go and learn them. If not, I wouldn't bother till you got through. It's too much effort. They're so long, painful. That one there is the unit circle. It's horrible. It's learnable and it's applicable, but wouldn't be losing sleep over it if I were you. You're going to lose 15 marks. It's not going to come up in a long question. It's not going to be right. You're going to lose 15 marks if it comes up if you don't know it. If you can learn a bit, start of it and have a whack off it, you'll get 7 out of 15. You only lose 8 marks, which isn't bad. But I wouldn't be going killing myself learning them. And that's the God honest truth. Alright? Right. Have a go at the bottom 2 bits. obviously we can't use the one straight out of the logbook, so I have to use the other one to sin A cos A. Just in case you're wondering, this actually didn't come up in an exam. This is this is 2000 and that's 2015 paper 2 question 9. This is exam craft. This is one of the pre's from 2018. So this is 2018 pre. Just in case you're wondering, 2018 pre, not the one you do next door in Newport. It's the other one. Sorry, this is the exam craft, not DEB. 2018 pre. You do that harder ones. And first, cos of 2A, we have to use that. Second, 2 there for cos of 2A. We got to try to do it. Cos squared A minus sin squared A. Sorry? No, use the other. Is there not? There's 2 cos of 2A's, is there not? No, is it? There's only one cos of 2A formula. Right, what are we going to use?
Double this. Or what I'd actually do.
Yeah, right. What I'd actually do there is, does everyone see top 14? So, you can manipulate any of these rules. Now you can use the, alright, a second. You can do this one of 2 ways, just looking at it. You can use this rule. That's equivalent there. Half times the top. 1 plus the cos of 2A. You can use that rule and manipulate it around till you get cos of 2A on its own. Or, just what I'm just looking at there now, I'll be using I'd be using this one as the top. And then here I'd be using this one as that, even though this one has cos of 2A. So right, you can manipulate this around, you get the answer. I can't see it at the moment how you do it. You can get the answer doing that. I just can't see it. Unfortunately, I don't know whether you can see it or not. Anyone any idea why I use this? Cos and sin, and also what's cos by cos? If you multiply cos by cos, what you get? Forget about the letters. We'll say that's cos of x by cos of x. Cos by cos, then cos of x multiplied by cos squared. Alright, what are we looking for? Cos squared. Okay. Multiply sin by sin. Sin squared. So, anyone, any idea how this is going to help me when they're looking for cos of 2a? Change cos of 2a, cos a plus a. Cos of 2a can be written as cos a plus a. Is that okay? That makes sense? As I said, that one will jump out with you straight away because the cos of 2a in it. But just seeing cos by cos and sine by sine just makes more sense. Don't worry, guys, we're nearly there. 15 minutes. I know these are very brain flying. Right hand triangle. It says here to 360 you do the unit circle. So, cos of 2a would become cos of a plus a, which the formula for cos of a plus a is cos a by cos b, but because it's a, it's cos a by cos a minus sine a by sine a, which is cos squared a minus sine squared a. And it's handy as that. Right, bottom bit, off you go. I'm only giving you 5 minutes now to do your bottom bit because this is the third one of these I've done today, so I'm going to get this one right. root 3 over 2, 60. So, it's positive, isn't it? C, so it's 30 over here, and it's going to be 300, right? So then 3x is going to be equal to 33 plus 360n, and then 3x is going to be 300 plus 360n. So what's that? 3x is going to be equal to 10 degrees plus 120n. 300 plus 120n. If you want anything 0, and you want anything 0. Sorry about that. Right, correct that for you to on the last bit. There's a unit circle C A S T. 3 theta is equal to the cos of root 3 over 2 is 30 degrees, is it? So theta is going to be 10 degrees. So up here and out here, this is going to be 30 degrees, and this is going to be 330 degrees. So 3 theta is equal to 30 degrees plus 360n, or 30 degrees plus, not 30 degrees, 3 30 degrees plus 360n. We all happy there? Divide across by 3. Theta is going to be equal to 10 degrees plus 120n, or 110 degrees plus 120n. N equals 0. That's 10 plus 0 equals 0. 10 plus 0 equals 10 degrees. Or n equal to 1 is equal to 10 plus 120 times 1, which is 130 degrees. N equals 2 is equal to 10 plus 120 times 2, which is 250 degrees. Over here then, that's 110 degrees plus 120 times 0, which is 110 degrees. 110 degrees plus 120 times 1, which is equal to 230 degrees. And 110 degrees plus 120 times 2, which is equal to 240, and 110 is 350. 350 degrees. So your answers then are 10 degrees, 110 degrees, 130 degrees, 230 degrees, 250 degrees, and 350 degrees. Is that okay? Can we see how important this question is? We've literally hit it 3 times, and we've only gone back 4 years on exam papers. It didn't come up last year, to the best of my knowledge. I'll double check that it didn't, so it is a nice little one to get your head around. Right, before we finish up, something we looked at last week, but I want to do a little bit more looking at because it's a tough one. Also, we won't really be looking at TRIG again till May. So in this class, we won't be looking at TRIG again till May, like when we're revising paper 2. So it's important that you go over the videos and go over the homework whenever you have a few minutes, because bar you're looking at it in class and new revision, I won't be doing it here until May again. Is this question here. Right, 2016, paper 2, question 8. The height of water measured over a period of time. The average height was found to be 1.6 meters. The height measured in meters was h of t. So as a function, it was modeled using the function h of t is equal to 1.6 plus 1.6 4.5 times the cost of pi over 6 times t, where t represents the number of hours since the last recorded high tide, and pi over 6t is expressed in radians. So we're dealing in radians. When I'm doing this question, before I start, I don't have any idea what I should be writing down on the top of my page. You see questions like this, just so you can get your head around. What did I write on the board here last week when I was doing questions like this? And what is it? So this sentence is like cost of C. A plus B times the cost of C. Like, anyone remember what these letters affect? What's A going to affect? Man shifts up and down and so on, right? Start with it. B. Good lad. Range. And C. Here. Good on. Right, off you go. A and B. Ready, everybody's 5 minutes for forget. See if we can do part C, see if we remember our differentiation from 2 weeks ago. And we have L, yeah? And you remember what period for a regular cost graph is? Period means when it revolutionized, go back to the start from last week. 360, good work, but what we're dealing in radians, so for me, 2 pi. But remember now what I told you, what letter affects the period? The C. And what's our C here? Pi over 6. Which letter affects our range? B. But don't forget our starting point is affected by A, isn't it? And as I said, have a whack off C. See if you can remember differentiation from 3 or 4 weeks ago. What? B. Find the maximum height. No. I know what you're thinking. Yeah, you can do calculus on it, but there's no need. As in, it's just literally looking for the maximum height of the water. As in, how high can the water go? And we know that from off our range and our starting point. We know the water is not going to go above our range and our starting point. You could do differentiation, but there's no need for B. Right, we'll have a little go at this and we'll finish up then. Thank God says ye. So, my period for a cost graph is what? Usually 2 pi, i.e. in a revolution size is every 360 degrees. But what did I say affects the period here? Here, C. What's C? Exactly. So, to get your period, you say 2 pi over C, which is 2 pi divided by pi over 6. Calculator probably the easiest way to do it. 2 pi divided by pi over 6. Make sure to change it to rads and we're getting 12. In the context of this question, what do you think 12 means? Even just think about what the question is asking us about. Anyone who knows anything about water at all. Logically think about, anyone know anything about tides at all, no? Right, tides every 12 hours in, out. So i.e. they're going to change every 12 hours, high tide to low tide, high tide to low tide, alright? They love water, things like that, because tide actually moves on a periodical function of every 12 hours it revolutionizes. So, that's what 12 means there. The range. Anyone maybe give me the range? Faye, go on, you look confident as hell there. Any guess? You got? Brilliant. 3.1 down to 0.1. That's the only mistake you made. 3.1 down to 0.1. Why is it 3.1 down to 0.1? Where's my starting point? Looking at our letters, what's my starting point going to be? 1.6. The number in front of the cost tells me where it goes up and down, doesn't it? Go up 1.5 from 1.6 and you get 3.1. Go down 1.5 from 1.6, you're left with 0.1. And that's your range, 3.1 to 0.1. Find the maximum height of water and port atom. 3.1 meters. And the last little bit, find the rate at which the height of the water is changing when t is equal to 2 decimal places. What tells me this is differentiation? Rate of change. 1.6 plus 1.5 times the cos of pi over 6 times t. Anyone have to have a go at differentiating that? Differentiate 1.6, it goes to 0. Differentiate 1.5 times the cos of pi over 6 times t. 1.5. Differentiate cos is not sine it. Minus sine of pi over 6 times t. Is that the answer? By pi over 6. Don't forget you differentiate the trig and then you differentiate the x. Exactly. And we leave that equal to? Leave t equal to 2 then. So you literally then say 1.5 minus the sine of pi over 6 times 2 by pi over 6. Right, give me an answer for that. So we're getting pi over 6 multiplied by 1.5 is, bring the minus out to the front, 1.5 times pi over 6 times the sine of 2 pi over 2 pi times 2 pi over 6, which is minus 1.5 times pi over 6 is pi over 4 times the sine of 2 pi over 6, which is minus shift pi over 4 times the sine of 2 shift pi over 6. And we're getting minus 0.680174. Anyone, any idea what that means in the context of the question? Water is decreasing at a rate of negative 0.69 at 2 a.m. 2 in the morning, i.e. the slope of the water is going out. Right, you'd be happy to know you're finished.